Welcome to the second video of section 3.1. In this video, we'll discuss conditional probability. The conditional probability of A given B is written like so. The probability of A given that B has already occurred. We calculate the probability of A given B like so. The probability of A and B divided by the probability of B. Remember, and is the intersection or the overlap. Also, the probability of B is greater than 0. Looking at example 2, once again, let's roll a fair 6-sided die. And we're going to let A equal the event that we will roll a 2 or a 3. We'll let B be the event the face is even. So let's write the outcomes for each. So here is A and B. Example A asks us to find the probability of A, and we have 2 outcomes in A over a total of 6 in the sample space. For the probability of B, we have 3 over a total of 6. Taking a look at letter B, they ask us to find A prime or A complement, and that means everything that is not in A. So the probability of A complement, since there are 4 items here, will be 4 over 6. For letter C, they ask us to find the probability of A and B. And just keep in mind, often in many texts that can be written like this. But the probability of A and B means where is the overlap? That happens just at 2, doesn't it? They only share 2 in common. So that is just 1 item over a total of 6. Moving on to letter D. Letter D asks us to consider the probability of the A or B. So first let's find what's in A or B. Remember, this can also be written like this, A union B. And that means we could have it in one or the other or both. So we have 4 elements here. So the probability of A or B is 4 out of 6. Now, let's take a look at what's the probability of A given that B has already occurred. Let's go off to the side here on scratch paper. If we know that the face is even, we have a reduced sample space now. So out of these 3 possible outcomes, only one of these choices belong to event A, that it's a 2 or a 3. So we need to follow our formula here. The probability of A and B over the probability of B. We figured these out earlier. The probability of A and B is 1 over 6. And the probability of B is 3 over 6. And let's do a little bit of a review here to remember how to multiply our complex fractions. And in order to divide with a fraction, we have to multiply by the reciprocal. So the answer to letter E is 1/3. Let's move this up a little bit to make room for letter F. We'll use our formula once more, plug in the values, and we'll solve. Moving on to the next page, let's practice some of our symbols. We have a baseball team with infielders and outfielders. Some of the players are great hitters and some of the players are not great hitters. I will be the event. The player is an infielder. O, they're an outfielder. H, they're a great hitter. And N, they are not a great hitter. So for letter A, write the symbols for the probability that a player is an infielder. For letter B, write the symbols for the probability that a player is not an outfielder. We can write this using the complement sign, but also notice this will equal the probability the player is an infielder. For letter C, write the symbols for the probability that a player is an outfielder or is a great hitter, and we could use this, but remember, we can also use our union sign for or. Letter D asks for the probability that the player is an infielder and is not a great hitter, or we could write this using our intersection sign. For letter E, what's the probability that a player is a great hitter given that the player is an infielder? Letter F, the symbol for the probability that we have an infielder given that the player is a great hitter. The symbols for the probability that of all outfielders, a player is not a great hitter. So that would be the probability of N given O. And for H, the probability that of all the great hitters, a player is an outfielder. And go ahead and pause the video for a moment to see if you can answer letter I and letter J. How did you do? Hopefully you got it. And that is the end to the second video of section 3.1.